Humanity's mastery of the atom is one of our greatest technological achievements. Using small amounts of fuel, we can produce incredible amounts of energy. However, this process also creates some very nasty waste products. This waste is not only potentially harmful to human beings, but also, if released into the environment, could decimate ecosystems. So what do we do with radioactive waste? Nuclear waste comes in three different forms. The first, generally called low-level nuclear waste, includes items that have become contaminated with radioactive material. This kind of nuclear waste makes up around 90% of the volume of all radioactive waste. LLNW will generally consist of items like contaminated clothing, mops, reactor water treatment residues, equipment and tools, medical tubes, injection needles, and laboratory animal carcasses and tissue. The actual level of radioactivity of this kind of waste can vary widely, from just above background levels that you'd find in nature to more highly irradiated stuff from nuclear power plants. The second, called intermediate level nuclear waste, contains some long-lived radioisotopes and includes materials such as used reactor filters, reactor components, and some effluents from reprocessing. Around 7% of total nuclear waste by volume is classified as ILNW. The third and final kind, called high-level radioactive waste, is what most people would likely think of when they hear the term nuclear waste. These are highly radioactive materials, such as spent fuel and waste materials from the processing or reprocessing of nuclear fuel, and they make up around 3% of nuclear waste by volume. So how are these different types of nuclear waste stored and ultimately gotten rid of? LLNW can typically be stored on-site until any radiation contamination present completely decays, or until it has fallen to a level deemed safe for regular disposal. Typically, this can take as little as 50 years or so after storage. They can be disposed of relatively easily once radiation levels have fallen sufficiently, and this can be done according to the World Nuclear Association, almost anywhere. For this reason, most of the waste tends to be sent to land-based disposal sites, following packaging for long-term management. Such sites tend to be near surface, at ground level, or can be in caverns below ground, at depths of around 32 feet. This is the preferred method in countries like the Czech Republic, Finland, France, the UK, and the US. In some cases, LLNW can be shipped in large quantities to specialist disposal sites in specially designed containers that must be approved by domestic and international safety standards. For example, in the UK, LLNW is sealed in metal containers before being stacked in concrete-lined, highly engineered vaults in the low-level waste repository. When the vaults are full, a cap will be placed over the containers. Some LLNWs, such as plastic, textiles, and oils, can be incinerated. ILNW that contains long-lived radioisotopes may also be stored in underground depositories. In the U.S., defense-related transuranic waste is disposed of in the Waste Isolation Pilot Plant, which is a deep geological repository in New Mexico. A number of countries dispose of ILNW containing short-lived radioisotopes in near-surface disposal sites, like those used for LLNW disposal. HLNW can be very harmful to people and the environment. This kind of waste tends to contain significant amounts of radioactive fission products. Unlike LLNW, radioactive decay of this kind of waste can take thousands of years. So it must be stored and eventually disposed of using techniques of the highest safety standards. HLNW is often first stored on-site to allow the decay of radioactivity. This usually involves storing the waste in ponds or dry casks for at least 5 years. After this, it may be moved to a permanent underground repository, such as a deep geological disposal site. However, there are currently no deep geological sites that are operational. One example is the proposed Yucca Mountain site in the U.S. While waste is in temporary shallow storage at the site, work on developing deep geological disposal on the mountain has run into a number of problems. Other nations like China, Finland, and France are also working on constructing such long-term storage facilities for HLNW. This type of waste can also be reprocessed to recover feasible uranium and plutonium for use again in nuclear reactors. In cases where liquid HLNW is produced from reprocessing, this is first turned into a stable form of glass before being stored on-site for up to 50 years, before eventually being moved to long-term disposal, if this becomes available. Around 250,000 metric tons of highly radioactive waste is currently stored near nuclear power plants and weapons production facilities worldwide. While it waits for permanent disposal in yet-to-be-constructed geological repositories, this waste is emitting radiation that can pose serious risks to human health and the environment. As the hazardous materials and their containers continue to age, this situation is leading to new research in corrosion and nuclear waste disposal. But until a solution is found, the problem of nuclear waste disposal, which has been handed down to us from the previous generation, is likely to be passed along to the next.